Hi, I'm Amy Christman. I'm a Tioga Junior High School teacher in Rapides Parish. I teach on a true inclusion team with my co-teacher who is also certified in special education and middle school math. We have 9 students in the classroom that you will see today who range in disability from autism, other health impaired, and specific learning disability. Our students are very diverse academically. Their test scores range anywhere from unsatisfactory to advanced on the LEAP test. That, coupled with our inclusion students, makes it even more important for me to strategically place students in groups. That way, every student has someone that they can relate to, and it also provides the support needed for those lower achieving or higher need students. In today's lesson, you will see Module 4, Lesson 17 from the Eureka Math curriculum. At the beginning of each lesson, I try to model for the students what they are expected to do. After modeling one problem, I turn it over to the students for them to work independently or in groups. Today, they're working in groups to solve 2 problems and make their own discoveries. Okay, so if I just chose some points, I can choose like 0, 1, and 2. I would want to choose lower points because I would be able to graph them on the grid that I have without going off of the paper. I can plug in all of these x's into my equation and then solve for y to find out what my y's are. So y is equal to, let's do the first one, 2 times 0. So then I would write y is equal to whatever 2 times 0 is, which is 0. And then rewrite the equation. Y equals 2 times, let's find out what y is whenever x is 1. So y is equal to 2 times 1, which is 2. So when x is 1, y is 2. And then y equals 2. Students are working independently. I have a system in place for me to check which students completely understand, which students are almost there, which students have a few questions to help get them to where they need to be, and which ones are completely lost and need to be pulled for one-on-one intervention.
The x goes this way, right? The y goes up. So we're going to count 1. So go over 1. Over 2. And then go up 4. So 1.
You know how to go backwards, Bella?
It's like doing percent thing. Yeah, you'll go over 1 and down 3 instead of up.
Yeah. What is the point of that? Okay. Next one we do 2, 7. 1, 2. You go next.
So figure out what y is going to be. Use your calculator.
3.
We'll first stop and show
0.
whatever we're getting done.
I'm about to move in. I think I'll finish up the last one, and we're going to make a connection to what happens.
Yeah, because there's some of them are ready for that, but I don't want to go into it.
Okay, I just want to get them past this one.
So put your start right here.
Where are you getting that from?
Going down here in O2.
Yeah, where is that coming from?
These.
So when you plugged in 1, 3 times 1 is 3. Okay. But it's positive 1, positive 2. This is ending up negative. That's 2, 1.
I was thinking do 1 through 3.
2, negative 1. So where would you find 1, positive 2? Start at the origin, go up 1 over 1, up 2. And you already had a point there. So I think what you thought was that whenever I was correcting you on this one, that all of them were wrong, but they were all right. It's just that I noticed that you had it going through the origin, and I knew that wasn't knew that that wasn't right. That's why I made you plug in 0 to find the y. I didn't mean for you to erase it all. All of those were right, okay? So you were doing a great job of that, and I don't want to take that away from you. So these points are right. What you need to plot now to carry is, did you find out what it was? -1, so put -1 right there. So what you need to do is plot 0, -1, which would be right there on your line, or here, I'm sorry. Your line kind of moved over a little bit. No, just, it's a 0, -1. It's right there. So 0, -1. So where's your point for 0, -1? Yeah, you plotted it. Yeah, you don't need this one, the 0, 0. Do you understand that? So you can erase that one. And then you need to connect, when you connect all of these, I'll draw the line for you, okay? It's gonna go through -1. It's not going to go through the 0, 0. Yeah, you're okay. You got it, you got it. Just, yep, like that. And if you used your slope and you kept going down, so if you, let's say your slope was 3/1, so if you started here and went 1, 2, 3 and over 1, you would have your next point that you can connect, okay? All right, y'all ready to move on? Okay. After students have been working in groups for a period of time, I bring them back together as a whole class. At this point, I'd like to clear up any misunderstandings, talk to them about their new learnings, ask them to share out what they have been discovering in their work, and to make sure that they have mastered, or at least they're working towards mastery of the objective. Our line. If we look at these 3 lines, I want you to first talk with your tables about what you notice that's different about those 3 lines. Just looking at the lines themselves. Turn and talk to your neighbors about what you find different.
The first one, describe perfectly on the origin. Second one, the storm on the
Okay, so the third one, it's above. This one's 0, 0. The second one's below, and the first one is exactly 1, 0. See what I'm saying?
All right, so I want you to kind of come back up here and let's talk about the differences in just the line. Bailey, what is one thing that y'all noticed about these 3 lines?
The second coordinate. Yeah, right there.
Okay.
It's
not like white in the middle.
It's not, okay, so
not
what,
in the middle.
so what do we call it when it's in the middle like this one?
It's going through the origin.
It's going through the origin, and this one is going below the origin. So it's crossing over, what do we call this?
The y-axis.
The y-axis, below the, just below the origin, compared to this one. What's going on with that
It's
one?
going above.
Okay, it's crossing the y-axis just above the origin. So now I'm going to put your equations that went with those. For this one, I already did, y equals 2x. This one was y equals 3x minus 1, and this one was y equals 3x plus 1. And I want you to think about what your slope was for each one of them. So what was the slope for the first one? 2. What was your slope for the second one? 3. Okay, and what was your slope for the third one? 3. Okay, so I want you to look at the slope. I want you to look at the line. And I want you to look at the equation and talk to your neighbors about what kind of connections you can make between the equation, the slope, and the line. Go ahead.
This one is also because it's -1, but this one is above the origin because it's +1. And this one's in the middle because it's just the 2 or the number
It
x.
starts at 0,
Yeah.
but it's starting at a different
Yeah,
spot.
and it's also just like 2x, not plus.
Gracie, share with us what your table said about all of this, all the things.
That the 3x, the slope was like 3. So how to make the coefficient is the slope.
So they kind of made a connection that the slope is always happens to be in front of the x. It happens to be the coefficient. The slope for this one, look at that, it's in front of the x. So it's the coefficient. And the slope here is in front of the x. What else did y'all discover on Zoe's table?
Well, we said that since the first one was just 2x, but you didn't subtract or add anything, that's why it wasn't like below or above the origin.
Okay.
But the other ones below and minus and above.
Okay, Haley, you want to add to that?
The first one is a proportional relationship, and the other 2, since it's subtracting one is underneath the origin, it's adding one is above the origin.
So she knows that this one is a lot like this is a proportional relationship. So what is our equation for that? What is the equation that we used? Y equals kx, where k was the constant, right? And so there was no plus something or minus anything, so it went straight through the origin. But we noticed that whenever it subtracted 1, our line dropped down 1, and when it added 1, our line went up 1. So what we call this.
I also want to make sure that when students are learning, that I make their learning relevant by connecting it to something they know.
Y equals mx plus b. Plus b, where m is actually the slope, and we call b the y-intercept. Okay, so I want you to think about this. A lot of you know about football, right? So if a quarterback throws a pass and the defense catches it, what is it called? It's called interception. And so whenever the line crosses or the y-axis catches the line, that's called the intercept. So the intercept for this one is 0, -1. The intercept for this one is 0, +1. Okay? And what do you think the intercept for this one is? The y-intercept for this one?
0, 0.
Is it what?
0, 0.
0, 0. That's correct. So we could write 0, 0 for the y-intercept on a proportional relationship. It's going to go straight through the origin. All right. So now what I want you to do is you're not going to use your graph this time. For the next 2 equations, 4 and 5, it wants you to just name what the slope is. So work in your groups to determine what the slope is for the next 2 equations.
After I have ensured that students are at least working towards mastery, I release the rest of the problems or exercises to the students to work on. Eureka does a really good job of scaffolding their lessons so that we begin with conceptual development, move into the more procedural type problems, and towards the end of the lesson, they are applying their learning. Towards the end of the lesson, I realized that we were running out of time. We weren't quite where we needed to be, but we were almost there. I need to be able to measure what they've learned so far in this class, so I gave them what we call here at Tioga Junior High a clueless ticket. It was created by one of my colleagues, and I've adapted it for my classroom. On this exit ticket of sorts, I asked students if they can write everything that they learned. If they had to teach a friend who was absent today, that friend would be completely clueless and would need to know what to do. So students spend a little bit of time in reflection, thinking about what they learned and putting it down on paper. On the back side of that clueless ticket, students are also tasked with creating a problem that would assess their friend who is absent for the day. Thank you so much for being a part of my classroom today.